Okay, so this one's talking about exponential growth. It says giant salvina, okay, which is like a plant thing, was discovered on Caddo Lake in Louisiana, and soon after was spotted in Texas. At the time, 10 acres was found to be infested, and it was found to be doubling in the area every 10 days. So what we know is when we complete the table, we want to come up with an equation for what the growth is, so they can make predictions as to how to treat it. So start out. One of the key things is, where are you starting? Okay, if we start at 0, before they start counting time, how many acres are affected?
10.
10. Notice here it says 1 equals 10 days. So if we go to 1, okay, we've done 10 days later, and so we've got 28. This is what everybody's been missing. What about 2? 40, not 80, doubling. 40. 3, 80. 4, 60. 5, 320. 640. And 1280. Okay. So the key thing first is to make sure that you have on your graph, on your table, you have the correct numbers. Then we're going to put this in and we're going to find the equation of the line. So let's go to your calculator and let's enter okay, sorry, computer glitch there. We list this, we start with 0. 1, 2, 3, 4, 6, 7 for days, which actually is how many days? 7 days represent 10 days. But it's actually about 70 days. Okay, so we start out at 10 and we doubled it each time. Okay. So we have our equation here. We want to find out the equation 1. It's extremely important that you go to variables because a lot of you did this on various tests and things like that. We want to be able to look at the table, the complete table, not just part of it, the graph, all those things. So we want to go like we've done before, stat, calculate, but this time we want to get exponential because it's not linear, it's not quadratic, it's down here at, what would be 10? It says 0 on there. So if you're just picking the number, you can pick 0. So I'm going to pick exponential, go to variables, we've always done, y, and get equation 1. Some of you still are not writing your equations. You're giving me this as an answer. This is not your answer. Your answer should be, when you write the equation, y equals 10 times 2 to the x. I don't want you to list out individual things. You're going to substitute them into the equation. This is your equation. We can get a general idea of our graph, but we're going to adjust the window a little bit. We go from 0 to 10 for y, or for x, excuse me, and 0 to, say, 1500 for maximum for the y value.
What did you put for the...
Just off the window. 0 to 10, 0 to 1500. And so that's in general what our graph should look like. If we should go to transfer that to our table, we have to adjust our labeling a little bit, but down here are your days. I would just count them up to 10. 4. And this side is our acres. So we start at 0 here. We need to go at least to 1200. I think yesterday they were talking about 15. And so you can split it up. If we say 1,500 and you have 20 spaces, how do you tell which county? Yeah, so what's 1,500 divided by 20?
75.
Okay, so if you needed to, you're counting each of these by 75. Because we've got our points, these are going to stay pretty low down here. 0, 10, 120, 2 goes to 40, 3, 80, until we get up to 7, which will be up at 1280, up in here. So it starts out kind of slow, and then it increases pretty quickly. Let's think about, this says on 30, what does the A represent? Okay, well if A is 10, what in this problem did A represent? Okay, it was the initial amount of acres that were affected, right? Remember that word initial that we talked about before? That's your starting amount. So A is going to always be what you're starting with. B in this case is 2. What does the 2 represent?
Because they're doubling.
Yeah, it's doubling. It doubles every 10 days. Okay, so what we can look at, you're going to see a formula in the next few days that we're going to deal with. And it's going to say that you have a rate, you have 1 plus your rate. That rate's in a percent. If it's doubling each day, what percent is that it's doubling? If I have, you have 10 acres today, 100%, not 200, it's doubling it. It means it's taking what you have plus the other 100%. Well, what's 100% in a decimal? 1. And so if we have 100%, that's 1. That's where the 2 comes from. Okay, the 2 itself is not your rate. 100% is your rate. So we end up with because we started up there at the 0 days, it started at 10, and we're increasing down here. I have another equation here. Okay, so if we go down to 10, how many acres are affected? 1,024. So that's what we want to have for, how many are affected after 100 days? 1,024 acres. Now this one says Kettle Lake covers 33,000 acres. How long will it take the entire lake to be covered? We were looking for in our table here.
33,000 acres on the farm.
Yeah. So we're looking for 33,000.
So it'll be about, wait, in between, isn't that 10,240 there? On number 10?
Oh, yes.
You put 1,000.
Sorry.
Okay.
10,240. There we go.
Um,
Okay, so we're looking for 33,000.
15 days of
That's 327.
It would be in between 11 and 20.
We're looking up
in between
here.
110 and 120 days.
So one thing we can do is we can say, okay, if it's somewhere in between here, we can do, get our table,
How do you do that?
second table, maybe 11.5, and I'm going to actually count it by 0.1. This is another thing that you've got to be able to do with your calculator. You've got to be able to adjust it to see what you need to see. And so then I can see here that 11.7
How did you do it?
is going to be the closest. Second table set. That's where we always change
I was
it.
pushing.
Right? And so we can see here that it's about 11.7, and that's where We have 11.7. How many days is that actually? 117. So it's approximately 117 days. I'm just going to put the answer up here on these so that if you need to go back and look at it. There's our table. And there's the answers to the rest of it off of our table. And remember, we're always using the exponential regression on this one to find equation 1. And be sure to round it.